Okay, so we're going to talk about rational expressions. Again, rational is just a code word for fraction. So we're talking about lots of fractions. The first concept is this idea of restrictions. We've kind of talked about this a little bit when we talked about where is the graph not continuous, at what values, at what x values. That's basically what a restriction is here. We're saying that the denominator, in this case, like x minus 3, so if you set the denominator, each factor in the denominator, x minus 3 equal to 0, and solve, you get x equals 3. So one of the restrictions will be x cannot equal 3, because if x was 3, that would make the denominator 0. That's a restriction. Now look at this factor right here. So we have x plus 2, so set x plus 2 equal to 0. Solve it, you get x equals negative 2, which means x, the restriction is x cannot equal negative 2. That's a restriction on the graph. And then this is actually a factor here. So we're going to set that factor x equals 0 equal to 0. Solve, well, it is equal to 0. And so x can't equal 0. So there are really three restrictions here. X can't equal 3, can't equal negative 2, and x can't equal 0. Because if they did, the graph would be undefined there. The graph would be not continuous at those points, discontinuous. So is the rational expression the simplest form? Well, I don't think it is. You can probably tell that that's going to cancel out really nicely there. Let's see what else is going to cancel here. So we've got the 2 and the 8. So that's going to be 4 right there. And then 1, when you cancel, something is left over. I've got x squared there and x to the first here. So I'm going to get rid of x to the first. I'm going to get rid of this. So now it's just x to the first. And I think we may have simplified it. So now the numerator would be just x. The denominator would be 4 times x plus 2. And so, and you could distribute that. That would be fine. But there's no more canceling to be done. So it's in simplest form there. So if you're given a generic kind of rational expression, generally, first step, factor both the numerator and the denominator, right? So we're going to factor this and see. We've done this a lot with the rational expressions we've been dealing with the last few days in class. So factor the numerator if you can, and factor the denominator if you can. I'm guessing they both can factor. Let's see. So this would be x and x. This isn't too bad. Factors are 1 that add up to 2, maybe 1 and 1. All the signs are positive, so plus and plus. That works. And then we'd have x and x. Let's see. Factors are 2, so it might be 2 and 1 if it works. They're both positive, and if you expand that, it does equal that, so that works. Now we see that there is a little bit of canceling that can be done. And so the simplest form of this fraction, this rational expression, would be x plus 1 over x plus 2. I prefer to use parentheses every time. It's just a good habit to get into. And really, when I say it's the fun part, I mean, that canceling, that's so satisfying, right? I mean, if you're honest with yourself, you realize, like, it's really fun to cancel out stuff. So I only got to cancel out one thing. Maybe on a really good problem, I'll get to be able to cancel out more things. Don't forget to identify the restrictions of the original function. Oh, okay. So look at this function, especially look at the two denominators here. So x plus 1. So the restrictions would be x cannot equal negative 1. And here, the restriction would be x cannot equal negative 2. So there are two restrictions for this graph. So you really need to be able to identify the restrictions like on that last problem. Well, we mentioned the restrictions on that problem, I guess. Let's try another one. So again, simplify. It's a matter of, just practice this skill. So you want to factor the numerator, factor the denominator. Hopefully these will factor. In fact, so far the factoring has been kind of easy here. So x and x. Factors at 10. 10 and 1 don't add to 7, but maybe 5 and 2. And both plus here. And this one, x and x. Factors at 10 that add up to 3. Maybe 5 and 2 again. But this time the bigger number must be negative, so minus 5 plus 2. So we have some canceling that can be done here. And so we get x plus 5 over x minus 5. And that doesn't cancel. So that's simplest form, but the restrictions would be, again, before canceling, x cannot be 5, and x cannot be negative 2. And I think y'all are getting that. So be careful with parentheses. Always use parentheses. Again, I just want to mention that. So like you want to factor all these guys. This division sign is really a grouping symbol. So you might want to think about it that way. It might help you kind of simplify the thing. So like this first one here, that can be factored to GCF, maybe 2 times x minus 4. This next one here, so let's factor that one. This would be x, so maybe 4 and 1, both positive, both plus. Okay, and this one should be able to factor there. So this would be x and x, 2 and 2. One's plus and one's minus. And finally, the last one, we got x and x. 4 and 4. Oh, 4 and 4 work. 4 and 4. And plus and plus. And since these are all multiplication here, since there's multiplication in between each thing, so we couldn't do this then, but now we can. We should be able to cancel even if they're not directly on top of each other here. So, well, x plus 4 cancels. It's really hoping for more factoring to be done there. Unfortunately, x minus 4 doesn't quite cancel x plus 1. So it really doesn't cancel here. So we get in the numerator 2 times x minus 4 times x plus 1. And then the denominator x minus 2 times x plus 2 times x plus 4. And we have restrictions. X cannot equal 2, can't equal -2, can't equal -4, or +4. Just looking at the 4 factors there. Oh, wait, -4, I already said -4 twice. No need to say -4 twice. So that factor is repeated. And so those would be the 3 restrictions for this particular function. Again, just more practice for this. Getting the idea here. So always factor first. If it can be factored, you want to factor that. So this one would be, let's see, I think that factors. So x and x. Factors of 6 adds to 1. Maybe 3 and 2. Adds to +1, so I think that would be plus and that's minus. And hopefully you see difference of squares there. That would be x minus 5 and x plus 5. And in the denominator, we have x minus 5. And this one would be x plus 3 times x plus 1. And cancel, this is the fun part. X minus 5 goes away, x plus 3 goes away. That's it. Still pretty good. X minus 2 times x plus 5 all over, x plus 1. Don't forget to label the restrictions. X cannot equal 5, -3, or -1. So again, before you cancel, think about the restrictions there. So I'm looking at that, not after I cancel, but before I cancel for restrictions. Just one last concept here. Yep, okay. So dividing rational expressions here. So if you've got something like, here, let's do this one first. So dividing by a fraction. So if you've done this kind of problem before, you know, you take the first fraction, you multiply by the reciprocal. So you're going to flip that around. So this will be 4 over 3. And by the way, you are allowed to cancel here because this is all multiplication here. You can cancel the 2 and the 4, and that makes it 2 there. And so we get, the answer is 2/3. So all that nicely simplifies. 1/2 divided into 3/4 is 2/3. So be sure to change the divisor before you do anything. In other words, if this is division here, what I might do first is I might just, okay, say this guy's got to flip around first. It's got to be the reciprocal of that second function here. So you could do that first. Like this first fraction is going to be what, x plus 4 times x plus 1. I don't flip the first fraction, just the second one. And this would be x, let's see, maybe 3 and 4. and the bigger number is positive, the smaller number is negative. And then times, and so I'm gonna flip-flop these. So this is gonna be up top, and this one's gonna be down low. So down low, that's gonna be factored to be x plus 1 times x minus 1. And up top, if we take out a GCF, hopefully that'll help. 2x seems to be a GCF times x minus 3. Okay, there's all multiplication now, so we can have the fun part, canceling things out. That cancels. That cancels, so this is fun. That cancels. Wow, this is actually pretty good. So we get 2x over x minus 1. Don't forget to talk about restrictions, right? X cannot equal, if you look down here, 3, -4, -1, or 1. So all those values are restricted values. And again, we just have one more problem there. If you'd like to do it, ooh, I like this one because there's going to be one like this. Ooh, you need to know how to do this. So this one's just a little bit trickier. Again, because it's division, there's division right there. Don't forget, you're going to have to flip or do the reciprocal of the second fraction here. So let's try this one and see what happens. So on top of the left, you have 2 minus x. Here you have x plus 1 times x plus 1. And then times, and up top, you're going to have x plus 1 times x minus 1 when you factor difference of squares there. And if you put this down low, that's going to be x and x, hopefully this factors, 5 and 2. The bigger number's positive, there we go. Okay, let's cancel out anything we can. So maybe you see x plus 1, that's nice. No x minus 1, but I'm really close. I don't know if y'all see it, but like these two are so close to being the same. Like they're almost the same. So if we could figure out a way to get them to be the same, because they're actually exact opposites of each other. And the way I like to do that is I like to take out a negative or factor out a negative from both terms. So up here on the left, you would have, if I factor out a negative, that's going to be both signs change. So it's going to be x minus 2, or you could say -2 plus x, which is the same thing as x minus 2. But I have a -1. I'm going to write it as -1 out here. It might actually help you to write -1 right there. That's being multiplied by x minus 2, divided by x plus 1. By the way, I can write this as one big fraction times, that's perfectly fine to do. So this would be x minus 1 and x minus 2 times x plus 5. And so now it does look like there is additional factoring or canceling that can be done. And so we have our answer, which is negative x minus 1 over x plus 1 times x plus 5. And again, don't forget to mention the restrictions. X cannot equal -1, 2, or -5. Did I miss any? Oh, wait, for this one. Let's see. So this is an interesting one because the original problem had x squared minus 1 here. It's interesting. So let's kind of explore this a little bit further. I'm going to graph this. I want you to see something. Okay, I graphed it. It's kind of a complex graph there. It's hard to type in. So let's just plug in a few values. If I plug in -1, you can see it's undefined. 2, it's undefined. -5, it's undefined. The value I want to test is 1. I want to just see what happens. So what's interesting is 1 is also undefined. The reason for that is you look at the original problem, x squared minus 1, if you factor that, you'd have x plus 1, x minus 1. And so even though the final product doesn't have x minus 1 there in the denominator, the original problem did. So you need to look at not only the denominator here, but also the denominator here. So after you have reflected. So you've got to look at both to get the restriction there. That's it. That's about as complicated a problem as you'll see in this section.